Hey there, and welcome to Cafe Dev. For today's episode, we will see how we can use AI at the edge. What means the edge in this case, and what we will do in AI. We'll do a bunch of things. Let's get started. Welcome back on Cafe Dev for this last episode of JulyOT. If you don't know, during the month of July, I've been doing 5 live video stream around IoT. I will refer to previous episodes, so if you haven't watched the previous episodes, that's totally fine. You can find them on my YouTube channel, Cafe Dev. And with that said, we will start talking about today's episode around using AI at the edge. And for this, I welcome back my last week co-hosts, Paul. Hi, Paul.
Hey again, Chris. Hey, everyone out there. It's a pleasure to be back again talking about a really exciting topic, artificial intelligence at the edge.
Yeah, I think you have done a lot of things in this area previously.
This is partially the area I tend to play around with the most, I'd say, like in the last couple of years. So it's very near and dear, and it's really exciting. I hope that we can make this type of field and these types of solutions that you can build with these technologies very accessible to folks that are watching this material, because it isn't as hard as it sounds. As you'll see with a lot of the services that Microsoft has created, they've really made it easy to empower just anyone to pick up and start making use of really cool things like, speech detection, things like object detection. It just goes on and on and on. We've more or less turned AI into a service, and hopefully we can show you how you can wield that today in your own solutions.
Yeah, and you made a really great point. If you're a developer, if you don't know anything about the AI or maybe anything about IoT, that's fine. That's totally okay. You can follow us along with today's episode, and you will be able to do something even if you have no prior knowledge around IoT. And if you're already a seasoned AI developer, I think at the end of the show, we will have a short discussion, a quick chat about other ways to do AI at the edge, and you can find interesting things in this conversation as well. So let's get started. I will share my screen. So again, as with any episode in this series, you can follow along what we're doing by just going to aka.ms/JulyOT/learn. I've posted the link in the YouTube channel, so feel free to click on it and to follow along. And if you have any question during the live show, please ask us directly within the YouTube chat or the Twitter if you're following us on Twitter. So when you're going on the aka.ms/JulyOT/learn link, you will jump on the JulyOT Learn module collections. So it's basically all the modules we've done in the previous videos. And for today's video, we will do the connecting IoT devices to cognitive services using Azure Functions. There is a lot of words in there and a lot of services you may not know. So maybe we can take a step back and actually explaining what we want to achieve there. And we will do this also today with a piece of hardware. Is actually from all the series. It's the only module that requires to have some piece of hardware. And for today's show, we will use the MX chip board. I will share it. Paul, do you want to introduce basically what is the MX chip?
So the MX chip is a nice developer kit that essentially has a bunch of onboard sensors, and as you can see, an LCD display there that allows you to essentially prototype IoT solutions using a variety of the things that are present on that board. And those include things like there's a humidity sensor, pressure sensor, I want to say a gyroscope, a couple buttons, a magnetometer, a RGB LED,
Yep.
all sorts of different things. And if you look up in the upper left, the way it gets online is it has that onboard Wi-Fi module. So it is actually an all-in-one device that you don't have to worry about, say, wiring up your sensors appropriately. It's all just there, ready to go. And I believe these are available in a number of different kits that you can get. These cloud developer kits or IoT solution kits. There's different vendors that sell them, but if you look for MX chip, the letter M as in Mary, X as in xylophone, chip, you should be able to find these available.
Yeah, and there is as you said, there is a ton of sensor, and one of the cool things there is in there is actually there is a microphone. And during today's module, we will actually create a translator. The idea is to simply push a button, say something, and have the translation displayed on the LCD screen. That's what we try to achieve today. So when we are saying using AI at the edge, actually there is different things, because here we will use the MX chip, but we will not execute the AI on the edge. We will use the AI at the edge. You can do some AI things on the MX chip, but it's quite limited and what we want to achieve there is a lot of different things, because we need to first do some speech to text, and then being able to translate that text to another language to display it. So it could be very difficult to, or maybe even impossible to do it on this very low power device, because it's a device that has a very limited amount of memory. We are talking about megabytes of memory, few megabytes. So what we do here is we actually we will use some AI that is hosted on the cloud. We will see what what kind of AI is it, and what we do is we will send the audio directly to the cloud. We'll see how we do this in a minute, and then we will receive the translation directly. So for doing this, one of the things that is mentioned in this module is the cognitive services. So that's one piece of the equation, and the other one is the Azure Function. Maybe Paul, you can introduce us to what are the cognitive services.
Sure. So cognitive services is kind of our suite of AI as a service offerings at Microsoft. And this includes quite a few different, I guess what you would call common AI techniques. So one being, of course, the one that you are talking about right now is that ability to translate. And you can do this even from audio. So you could do this from text. If you had like a typed text, you could translate that. That I think we've all seen, but being able to do, where you're speaking and that's live translating. So you can sort of think of, futuristic sort of Blade Runner type of scenario. But that's not all. There's actually quite a few different things here. For example, just in the area of language, you have things like Lewis, that you can actually write these interactive applications that can essentially parse out written text or speech into intents that can then drive behavior in your code. So you could sort of think about, automated phone services, I guess would be one way to really easily grasp this. You can build out services where it can actually understand what you are saying and then cause that to execute different pathways in your code to surface up a variety of different user experiences to your end user. Similarly, if you were to go check out like some of the additional offerings under speech, there's different things there, as we had mentioned, which we'll be seeing here. So speech translation, text to speech, and also the opposite of that, speech to text, which can be very, very useful. And another interesting one, which is speaker recognition. So knowing who essentially is speaking, given some metadata about the users in that system, but being able to know like, hey, this individual is the person giving that command, and being able to adapt to that based on what's coming in. Then what's the one I really like is very exciting is you'll see there's a whole suite of offerings under the vision section.
Yeah.
And these do a variety of different things. For example, you can do custom object detection, or things like being able to detect faces as well as emotions of individuals that might be in a picture. Another really powerful one that we're seeing a lot of use in, especially in enterprise scenarios, is the form recognizer. So with this, you may have seen this in action for folks in the United States. If you were filing your taxes recently and perhaps you were using an online service, there was a lot of those where you can actually just upload your tax documents, and in something similar to this, possibly even Form Recognizer in the background will parse out all of the information in those fields and make it so you don't have to transcribe that yourself. And we find that's really useful in a lot of different business cases, especially where there's written documentation that needs to somehow be turned into a digital format for archiving. And as you can see, there's the ink recognizer, which, similar to what you're using on your whiteboard,
Yep.
allows us to know, it gets context. It's based on the rough abstract shape that you're drawing. It knows what that is, and locks that in more personally. And also our video indexer, which is just amazing. If you upload videos to that service, it can automatically transcribe it, but also start to index that content for you in a smart way to know when perhaps you're like shifting on a specific topic, or can even do things like tell you who is speaking when, which is pretty useful. I know I use this a lot where I'll be like, hey, one of my teammates brought up something really interesting in a call. I wasn't able to maybe gather that. I can then go back to the transcription, click on their face, know every instance that they appeared in that call, and very quickly zero in on where that point of interest was.
Yeah, so there's a lot of different interesting services, and actually we will use two of them to do what we want here. So I will just move this and say it's cognitive services. Services. Ooh, I'm in a hurry. Services. So we actually need a piece there because we will need to do two operations when we receive the audio from the device. We will need to do a speech to text, and to do the translation. So for orchestrating this, we will use another service, which is Azure Functions. So here we will have an Azure Function. So basically, Azure Function is a way to host not a website, but to host a specific method of code. So we will just write one piece of code that will receive an audio file from an HTTP request, and then this piece of code will call the speech-to-text service from Cognitive Services, get the answer, parse it, and then call again the translation API from Cognitive Service, and then send the data back to the Amic chip. And one of the cool things this piece of code will do is actually we will receive the audio as an HTTP call, but we will return the HTTP request as soon as we get the result. So the Amic chip is not waiting for all this process to happen. We will basically do these processes in kind of a background, and actually we will send the translation from the cloud to the device using one of the features of IoT Hub, which is cloud to device messages. So we already see this in previous videos of JulyOT, and we will see one of the ways of using this with this sample. So obviously, on top of that, we will need an IoT app to do all the communications with our device. So our device will communicate with the IoT app, and the Azure Function will also communicate with the IoT app. That being said, I think we can start digging into my setup and how I've done the module. I've just done the module before because there is a lot of things to deploy, and deploying code on VMix chip, actually compiling the code for VMix chip can take a few minutes each time. So I've already built everything, but I will go through what I've done with you. So let's back to the module. And the first thing we need to do is to actually configure the IoT device within the IoT app. So you have everything there. If you want to have more details about how to create an IoT app and how to connect your devices to the IoT app, please check out the first video of JulyOT, because we went into greater details about how to doing this. If you already watched the video or already know how to do it, that's very basic. We create an IoT app and we create one device identity for this, and then we'll have to actually set up the MX chip. And there is a few interesting things to know there. First, there is a firmware, kind of an OS for this board, and you can find several firmwares out there. One of the two most used are the firmware for IoT Central. So IoT Central is a solution to easily build your IoT solution without having to code. And we have a firmware that directly connects all the MX chip devices and sensors to an IoT Central application. So that's one of the firmware, and the other one is a dev kit firmware. So it's a firmware that allows you to actually code your own program, to write your own program for the MX chip. So you need to flash the firmware onto the device. It's very easy. You just have to download a binary file from there. And when you connect the MX chip to your PC, you can see like a USB key, which is actually your device, and you can double click on it and drag and drop your binary onto it. When it's done, it will take like less than a minute. The board will actually reboot, and then you will be able to deploy your own code onto the device. Then the next step you need to do is to actually configure the Wi-Fi. As you said, Paul, this device has a Wi-Fi and Bluetooth connectivity. So you need to pair your dev device with your Wi-Fi router. For doing this, you will need to reboot your MX chip in a specific mode. So I will do it live there. So I will hit the reset button. I will click on the B button. I will release the reset button without releasing the B button. And the dev board will start in a specific configuration mode that, as you can see, allows us to actually connect to that board through Wi-Fi. So I said to be able to configure the Wi-Fi, you need to connect to the board on Wi-Fi. So what's going wrong there? Actually, when you're booting in this specific mode, the MX chip will become a router, a Wi-Fi router. And as you can see in the list of my Wi-Fi networks, I have a new AZC something network there, and it's actually the network that is created by my MX chip. So I just have to connect for a minute to this Wi-Fi network, and then when I'm connected, I will not do it live because I may stop the stream, but when you do it, you will end up in this Wi-Fi configuration page. So the MX chip is actually having an HTTP server that shows up this page, and you will be able to select your Wi-Fi and type your Wi-Fi password and click on configure device. The MX chip will reboot, and then you will be connected to the Wi-Fi. So I've already set up the Wi-Fi, obviously, so I will reset the device without touching any buttons. And as you can see, the MX chip is trying to connect to my Wi-Fi. and in a few seconds, yeah, here we go. It acquired an IP address from my DHCP, and now it's connected to the Wi-Fi, and it's displaying my application. So it's quite easy actually to configure the MXShip. So the next stage is actually to no, let me go to that one. No, but no, that one is not really interesting. Let's go to the next one. So the next one, we will deploy all the Azure services required for this specific application. So I will go ahead and show you my Azure Portal. And I've created a resource group where I've created a bunch of resources. The first one is the IoT app, very classic if you already know an IoT app. And I only have one device. Here. One device, which is my MXShip, and that's it. Then I've created a cognitive services subscription. It's basically to get access to all the cognitive services APIs we told you about earlier, and getting the keys and endpoints to use them. So I will use that in the Azure Function at a later time. And the latest component is my Azure Function. So we will see in a minute. I will go back to this while I'm showing you the code, because here is just the infrastructure, and then we need to actually write some code to do this. So for writing all this code, I'm just using Visual Studio Code, but I have a bunch of extensions and a bunch of setup to actually being able to write some Azure Function code within Visual Studio Code, and B, write some device code and build and deploy my device code onto the MXShip. So everything is explained. If you're starting this at home, everything is explained into the Learn module. Basically, you will need to search for an Azure IoT Tools extension in the marketplace. Is not an extension per se, is a collection of extensions, and within this extension, you have two very interesting for what we are trying to do. The first one is the Azure IoT App Toolkit extension, and the other one is the Azure IoT Device Workbench. So basically, the second one allows you to actually write your code, your device code within Visual Studio Code, and upload it to the MXShip. And if you pay attention to my device code, there is a file name there .ino. Paul, does it rings a bell for you? INO. What is it?
That is an Arduino sketch.
Exactly. So actually, you can program the MXShip as you were programming an Arduino. So there is a ton of samples out there for doing things with Arduino, and you can actually also use a non-MXShip board within Visual Studio Code. So if you want to do some Arduino programming, you can do things within Visual Studio directly. So for doing this, and it's explained there, actually you will need to install the Arduino toolkit, and also to configure Visual Studio Code to point to your own Arduino installation. So it's a one thing step. So if you're doing multiple projects, you just have to do it once, but you have to do this extra step of configuration if you're on a new machine and doing for the first time Arduino programming with Visual Studio Code. And then actually all the code has been already written for you, and you just have to open a sample project. So I have here, I think, yeah, a new Visual Studio Code window, and actually when you're displaying the command palette, you have a bunch of commands into IoT device workbench, and as you can see, I can upload the device code, I can configure device settings, I can create a new project, I can compile device code, and I can open the examples. And that's exactly what you will need to do to go through this module. Then you will need to select a board. You can either select the MX chip or generic ESP32. ESP32 is also a small board, programming board. I have one of them there just to show you what it looks like. So we go ahead and select the MX chip, and actually you will have a bunch of different samples. Very easy one, like getting some sensor data or updating the firmware over the air, etc. And then you have more complex samples, like the one we are using today for this module, the DevKit translator sample. So you just have to open the sample, and then you will have all the code written for you. But you will have to configure a bunch of things. Actually, you will have to configure things on the function side and also on the device side. So on the function side, you will have to input there your subscription key for the speech service, and also to specify the speech service region. So these two information, you will get them from the Azure Portal. If you go on the Cognitive Services and Key and Endpoint tab, you will have all this information there. Okay. And the last thing you will need to do is the here to set up the device name. So the device name is the name of the device you've set up in the IoT hub. And as you can see there, mine, because I only have one, is MXchip01. So is not really a great code, because it can only translate for one device. It's something we may be able to change quite easily, but it's not embedded into the product for now. So this, as I said before, the Azure Function allows you to host just a single method of code and expose it here with an HTTP endpoint. And that's it. And basically, within this code, we are doing a call to the speech translation service, where we translate with an audio stream. So the MX chip will just have to send as a body of the HTTP request the audio, and then we have the results. And here we are using the IoT Hub service client SDK to actually send a message to the device from IoT Hub. So if you want to have more details about how to do this, I think we talked about that in the first video of JulyOT. So that's pretty basic code within the Azure function itself. Just wrapping the call to the speech translation service. Now we need to do another thing, because as you saw, the audio, the MX chip need to actually communicate with the IoT Hub and also communicate through HTTP to the Azure function. So we need to configure these two pieces into the device part. So for doing this, we are actually doing two things. The first thing we are doing is using one of the device workbench command, which is configure device settings, and within configure device settings we can configure the device connection string. If you remember our first video of the month, each device within IoT Hub has its specific connection information, and actually you get them from the portal, or you can get them from CLI. And we saw, I think in episode 3, how to do it at scale. Because if you're going to deploy 1 or 2 MX shape, that's okay. You can go on the portal and do it on your own and copy paste things. But if you're about to deploy thousands or millions of devices, we have automated ways to do it as well. And the last step is actually to get the URL of the Azure functions onto the device as well. So for this, we first need to get this address from the Azure function itself. So I'm going onto the my Azure function. I've already deployed it. I will show you how to do it in a minute. And if I go to functions, you can see my only one function, which is an HTTP function. And if I click there, after a minute, I can get the function address. So it's here, and as you can see, there is an authentication code, which means if you don't have access to this, if you just have access to the address, you cannot actually execute the code. We need to have this key to actually being able to query my Azure function. So we need to set up this in the device, and we have done something very easy, is just defining a macro there with the address, and that's it. And then you can have a look at the Ino file, the Arduino sketch. But basically what we're doing is getting the audio, waiting for the audio, initializing the Wi-Fi, and managing the different states. And at some point, we will use an HTTP client on the device to actually send to this Azure function URL the audio payload and get the answer. As you can see, we are not managing the answer there because we are managing the answer in the callback of a message received from the cloud. So there is a bunch of interesting things in this code. There is a lot of line of code, like not a lot, but too much to go into details into this episode. But if you have any question about this code, please leave a comment in a video, and I will be happy to answer that code for that, or your question for you. Did I miss something on the code bar? I don't know.
Look at the function code maybe a little closer.
Sure. Do you want to actually call out something from there?
Specifically, so somewhere I imagine it's calling a cognitive services SDK or API endpoint.
Correct. So it's actually just these 2 lines of code required to call the cognitive services API, because we already have an SDK in C# to code in the cognitive services. So as you can see, where is it? Speech translation. Am I missing something? Azure devices, this is the device SDK. Interesting.
Does F12 work here? If you, yeah, where's that speech translation service? There we go.
Oh yeah, gotcha. So yeah, there is I forgot about this other class that encapsulates all the speech translation work, but actually, as you can see, we're using the Microsoft Cognitive Services SDK, and if we look at the code, it's not really so much complex. The main part is the way the translation recognizer is working is not really opening a wave 5. Is actually you open a translation recognizer, because basically we are using this API on a high-end device. So the device with the microphone will actually call the cognitive services most of the time. So what we're doing is we're basically opening up the microphone, driving up to the translation recognizer, and then the translation recognizer catch something and translate something. It fires an event. and then you get the results. So there is a bunch of code. All this code is basically here simply to replace this logic with basically having an asynchronous method that get a stream, an already created stream and non a live stream to do the translation. Yeah, but that's it. So now you need to deploy A, the function code, and B, the device code. And again, because you've installed all these extensions within Visual Studio Code, actually deploying the functions is as simple as right-click and deploy to function app. You can do it on your dev machine. For production, obviously, we will do differently. But if you're just doing some dev, you can definitely go the easy way. And for the device code, there is an IoT device workbench command, which is upload device code. And what this command will do, it will actually compile the sketch file and then upload the sketch file to the MX chip. And then reboot the device so you can have the code, your code running on the device. So maybe it's time to learn some French with you. So as you can see on my screen, the device is already boot up with my application, and I will go over to do some settings because you can actually, with example, select the input language. You cannot select the output language. This is hard-coded in the functions, but you can definitely select an input language. So I will go over and select French and validate with A. Yeah. Yep. And then I will need to hold B and to talk. And because the MX chip has a very limited amount of memory, I will need to, like the maximum amount of time I can speak is 1.5 seconds. So I will basically translate just words, but it's just a limitation of this specific device, okay? So let's start with a simple word in French. Bonjour. Bonjour. So let's see if the mic has get my, yeah. So as you can see, bonjour, bonjour in French means hello. Let's try something else because it's almost late in the day in France.
Laissez le bon temps
J'ai faim.
rouler.
Oh. J'ai faim. Let's see if it's not too long. And it's working. J'ai faim means I'm hungry, and I think it's an important thing to know when you're trying to learn some French. But we can do another language just to show that it's not a fake demo. Let's do some Russian. Привет. Привет means hello in Russian. And maybe the next question, the next thing you want to say when you say hello to someone is как дела? Как дела, which means how it's going. So it's working. We've done some. So we actually we haven't done some AI at the edge, but we connected the edge with some pre-trained AI. But that's not all the things we can do with AI and Edge, right?
There's, of course, all sorts of different things we could do, even just building off of the services essentially we've just talked about. So one of the things I find interesting is right now our architecture shows us essentially using a microcontroller calling to a cloud service. But some of these services that are offered in cognitive services can also be surfaced as containerized workloads that run locally. So while right now your device does require an internet connection in order to essentially perform that AI call, there is a way to take some of them, and you can see these listed here, package them up as a container, and then those will all run completely locally on the device. So there is no need to essentially be connected to the internet for some of these services to work. It more or less packages down that same service you know and love that would traditionally live in the cloud and packages it up as a local service that devices perhaps behind a firewall, behind a network, or whatever your edge environment happens to be can then make use of.
So if I take my little schema, which means this is a V1, my microcontroller is directly talking to internet and to cognitive services hosted in the cloud. But what you're saying is actually we can have a V2 with, let's try to copy paste this. Copy. So I can have another way, which is having my MX chip somewhere, having my network closed, so not having access to, maybe I have a firewall or something, so I don't have access to internet, and actually I can have an edge device somewhere that is running a container, and here I have my cognitive services, right?
Correct. And so that device, the one that would be running the containerized cognitive service, would probably be a microcomputer of some sort. I know some of these containers, it depends on which one you're choosing, have different requirements. Like some of them can require 4 to 8 gigs on the device. So depending, you might need to adjust the device that you're using. However, I've also noticed some of these that say they need 4 gigs run just fine on 2 gig devices. So your mileage may vary there. But all you really need at that point is a OCI compatible container runtime, something like Docker, to pull down the container, and it will then run it. And the way these traditionally work, like if you look at any of those services, they more or less work the same way. They will expose an endpoint on a certain port. So let's just say, for example, port 5000, and anything that's able to reach that port 5000, whether that's a local service running on the microcomputer edge device, or if you expose that to where, say, an MX chip could call it over HTTP externally, it will then receive a result. And what's beautiful about it is that result looks exactly the same as if you were to call the cloud service. So the SDKs that you're essentially familiar with are the ones that we were using on the MX chip, can more or less be reused for consuming the results of these services, because the shape of the payload that comes back is exactly the same as what you would get in the cloud.
So that's a great thing, but actually, if you look at my architecture there, I'm using some Azure Function, and maybe I'm doing more complex things. Like my example is very basic because I ask the cognitive services for translation, and I just send back that entire translation to the device. But let's say I'm using the speech recognizer service, and I want to authenticate user voice in a list of, like, authorized user voice. So my logic is a bit more complex in my function. How I can like host my function without having to host it on the cloud?
Oh, that's a great question. So the functions can actually be deployed as a locally running containerized service as well, which is really interesting. So you'll notice a lot of the edge offerings that in Microsoft's suite of IoT services, a lot of them are essentially mirrored counterparts of what you would expect in the cloud that essentially just run locally. So if you have a function that's defined and lives in the cloud, it is very possible to bring that down as a container, and that same function code could then execute on an edge device, or maybe something that's perhaps instrumented with IoT Edge, as we had seen in previous videos.
Yeah, because I'm starting to need to manage this device in another way or not. Because I have two containers, they talk to a make ship, the make ship needs to know how to talk to these devices. So definitely we can use their IoT Edge to manage all these things. I don't know how to write Edge, but basically, if you don't know what is IoT Edge, you can check out the fourth video, I think, of the JulyOT to get a grasp of what is IoT Edge and what you can do with it. So that's pretty interesting.
Well, I think you hit on a really good point here too, that if we're just to brainstorm here and list out the services, at least I'm aware of off the top of my head, that exists in a cloud form but also can be deployed as a containerized edge module. There's a whole suite of things out there. For example, if you're looking for storage, there's a SQL database on Edge that you can deploy. This is really great for things that are perhaps capturing telemetry and you want to store them in a organized fashion or using a relational database, and also comes with the benefits of being able to mirror itself to the cloud if you need. So where I kind of think about this, the canonical example would be, maybe you want to send a device to Mars and gather some sort of samples about the environment. You're using sensors on board a device. You could store that data into a locally running edge database. And then, of course, it might take you forever to transmit that data back. Also, it might be difficult to fly it back to the planet Earth. But let's just say you did. You could then retrieve that device and give it some sort of faster connectivity, and it could then mirror those results that are in the local SQL database to a cloud database. Perhaps a more graspable example for us is if you think about air-gapped networks or offshore oil rigs. Maybe you're out there connecting data or collecting data, but you don't have that fast pipe to send the data directly to the cloud. You can collect it into that local module, bring it back to shore, and then upload it at that point. But that's not all. There's also the streaming analytics is offered as a edge module. So if you're wanting to do filtering of, say, high throughput telemetry that's coming from your devices, maybe you don't want to send every single message, but you want to aggregate that over time. Time series insights is really good for parsing that data while it's in flight to allow you to summarize it into, hopefully shorter payloads that can facilitate your use case. And I don't know if I'm missing any others. I'm sure I am. Do any others come to mind, Chris?
You already, I think, thought about the biggest ones we may want to use at the edge. But actually, you described one of the patterns we see in these kind of architectures, which is we have an edge device that actually receive all the data from all the sensors, but all this data will not be sent to the cloud. We will only send already analyzed, already transformed data to the cloud. It could be either just signals, like something is happening with, I don't know, with this motor or this industrial equipment, or maybe a subset of the data. If you want to train your own AI from different factories. For example, and using IoT Edge in combination with IoT Hub and IoT devices can help you build these multi-tiered architectures where part of the data is going upstream and then hit device or service that process it and then send it back to an upper stream device as well. But if we talk about AI, we basically, since the beginning of the live stream, we are having a very cheap, very lightweight device that cannot execute any or almost any AI workload on it. But I do assume that we have more powered devices we can use at the edge to do real-time thing without having to actually communicate with an edge device to do all the AI inference, right?
Sure. So we can look at a couple examples. The first is an implementation of cognitive services containers used in a fun project over on Hackster.io. And this one uses that containerized service to translate retro video games. So you'll see there is in the GIF that's scrolling by, we're translating games into Japanese. There's one translated into French.
Oh, nice.
Another one. And the way that we're doing that is using a cognitive services container that's actually performing the OCR. Now, unfortunately, at the time that I developed this, and I don't know if it exists yet today, the translation still requires an HTTP call to some service. But all of the text extraction occurs locally on the device. And because of that, we can then get the translation and redraw it back onto the screen. And it's funny, I think the reason this was built was I took a trip to Japan and bought a bunch of games that I couldn't play. And unfortunately, just because of the language barrier, and unfortunately, our services will only do OCR on English. So this solution helps everyone but myself. I only speak English, unfortunately, but it helps everyone else. So if this is something you're interested in, definitely worth taking a look. If not, if the use case doesn't really grab you, it's still, though, I think understanding just the architecture and how this is put together, I think there's some interesting things to read into. Similarly, if we wanted to take this to more advanced devices, for example, NVIDIA has a whole series of what we would call embedded devices that run at the edge. And one of the offerings that they employ is this thing called DeepStream. And essentially what this is a intelligent video application pipeline in the form of an SDK that allows you to really easily do things like, if I want to take an input from multiple video streams and perhaps use an object detection model, maybe that's been created with Microsoft Cognitive Services, you can put all of that together, and it's actually pretty fascinating. Simply by modifying a text file, you end up with a solution that's optimized in all areas of the pipeline, meaning the acquisition and decoding of all of the video frames, the stitching them together for inference, the actual executing of your AI object detection payload is also accelerated, down to anything else. If you happen to be producing those results back to the screen, it will re-render those using GPU acceleration. And so for those, the architecture would look a little different, because this is not, you wouldn't have, say, an MX chip, as you said, talking to this. Everything just happens on the embedded device. And these are small. I mean, this is, in fact, I've got one on my desk here, just coincidentally. I can show a small device like this that essentially allows you to run these advanced workloads. And
it's the size of a Raspberry Pi almost, right?
Yeah, but basically, with the only difference being, it's like a Raspberry Pi on steroids, both in terms of there's a very beefy processor on here, 4 and 8 core, depending on which models you pick up, and a GPU. So this is an onboard 128 CUDA capable Maxwell-based GPU on board for doing things like onboard object detection, gesture recognition, audio extraction. All of that stuff can be done with these.
Cool.
And we have a few resources out there. If this has inspired you, perhaps you want to learn more, you want to take this to the next level. Our resident program manager for computer vision at the edge, Mr. Emmanuel Bertrand, has published a really awesome getting started project on GitHub that will show you how to essentially do object detection with multiple camera streams to detect anomalies on a manufacturing line. So specifically detecting bottles that would be coming down the sea, or cans if they're knocked over. So if you scroll down a little more, it'll sort of show you the end goal here. But what's crazy is this $100 device, and maybe, honestly, this workshop takes no longer than 2 hours. I've seen people complete it in 60 minutes. We'll introduce you to everything if you wanted to go further into object detection workloads at the edge. And finally, and you'll see there it's using models from Custom Vision. And if you scroll down, you can sort of see how that turns into, you build this model and you can actually start detecting cans it uses like an included video of scrolling cans that are scrolling by to sort of simulate the manufacturing process.
Cool.
And finally, there is one other project that I've developed. I was very much inspired by Emmanuel's project that takes us a step further into how do we do every one of these aspects from a customized fashion. So I'll show you all the details on how to create a custom model that could detect anything that you fancy, and then submit that data into Azure for viewing inside of, say, time series insights, which we talked about in the last call. Also Power BI, if you wanted to have secure ability to share intelligent video analytics across a team. That's all covered here. And the great thing is, I mean, this is deep. We do everything here from the device to building the stream analytics filter down at the edge to forwarding that data to time series insights and Power BI to automating the actual training and deployment of your updated AI model. In each of those sections is accompanied with a 2-hour live stream from Eric St. Martin, who's also on our team. And the cool thing there is if you have no experience with this, neither did Eric. So you get to sort of see him walk through this with those brand new, fresh eyes, asking the questions that we would probably see individuals ask. And I think this is a great way to, in this COVID-19 climate, to share these types of workshops with individuals. Unfortunately, we can't host these in person all the time, and it's hard to gather people into a virtual setting. But what we've done is sort of box this up for you in a virtual format that you can hopefully take on at your leisure and spin up and follow at as you have time.
Great. We're almost at the end of the today's streaming already, and I think we still have a ton of things to say about AI at the edge. I think we only scratched the surface of this topic. But meanwhile, we are wrapping up there. If you have any questions, feel free to ask them now, either on Twitter or on the YouTube channel. I will have a look at them. So if you want to complete this module, you have all the links in the video description. As I said, you will need an MX device to actually do this workshop end to end. If you don't have any MX device, you can buy them on the internet. In France, I don't know how cheap it is in the US. In France, it's like something between 40 and 50 euros. I think it's approximately the same price in the US in dollars, obviously.
I want to say like $60 or something like that, if memory serves me.
Okay, and if you cannot buy any MX device, you should be able, if you want to hack something, to actually register your voice in a WAV file format and actually send this to the Azure Function API. So you can definitely hack something. Maybe with your phone, if you're a mobile developer, or with the web, with HTML5 or another type of device, you should be able to hack something if you want to try out this workshop without an actual MX device. Well, it's already the end of this JulyOT series. I hope you liked the series. Do not hesitate to send me any comments in the YouTube comments or on Twitter. It's the first time I do personally a series of live streamings. And if you liked something, please say so. If you didn't like something or you were expecting something else, also please say it so we can adapt the next time. If you have one of the IoT topic of question that is not answered by this series, also feel free to add your comments. I can get more lives up and running or shoot some videos. Paul, do you want to say a few words about the whole JulyOT thing?
Yeah, so I mean, it was our intention to hopefully inspire our IoT devs out there and newbies alike to start to get interested in the whole ecosystem that surrounds IoT, which includes a lot of things, as you've seen, microcontrollers today, artificial intelligence, accelerated devices, all of those things. We're hoping that you could have been introduced to those through some of the content and series that Chris has put on, and hopefully you're inspired to build something with it. And we understand that not everyone's able to build these things in a week or a day, but like if you did happen to be inspired by JulyOT, please hit us up on Twitter. So I'm at PJ DiCarlo Cimano. Let us know, or use the hashtag JulyOT to let us know what you've been inspired to build, and we'd love to maybe follow up with that in a post to hopefully showcase the projects that we anticipate seeing from users. And if you are, if this is your first episode and you're not sure where to get started, you can just head to July, the letter O, the letter T.com, JulyOT.com, and all the resources for getting started will be there, and hopefully everything you need to get started.
Great. Thanks, Paul, for being my co-host today. Thank you all for watching this video, and I hope to see you very soon again on Cafe Dev. Bye-bye.